we are going from NCN to n plus kcn, right? So can we consider 1 plus x, right? This expansion, 1 plus x to power n plus 1 plus x to power n plus 1. And we go on writing this sequence, n plus 2. And let's, since they're asking to n plus k, you see there? So x, this is 1 plus x to power n plus k. So this sequence can be written as 1 plus x to power n. Let's take it common. And from here, we'll have 1 plus 1 plus x, because power n is taken common outside. And this would be 1 plus x squared. Yes. And this will go on like this up to 1 plus x to power k. Now look, inside the bracket, we have a geometric progression and the sum of n terms of our geometric progression. Sum of n terms is given by, yes, that's right here. Sum of n terms of GPSN is given by a time r to power n minus 1 over r minus 1. Okay, because here r is greater than 1, right? So this can be written as 1 plus x to power n as it is. And inside, we are going to use this formula. Since a is 1, the first term. And watch carefully, there are k plus 1 terms in this sequence, right? So not n. For n terms, we have this formula. For k plus 1 terms, because we have started from 1 plus x to power 0. Look, this one can be considered as 1 plus x to power 0. From power 0 up to power k. How many terms? K plus 1 terms. So we are going to write the formula for that. So in place of r, you can easily see common ratio is 1 plus x. So 1 plus x to power k plus 1 and minus 1 divided by 1 plus x minus 1. Look, this 1 gets cancelled. Only x is in the denominator, isn't it? So we would like to write only x there. Okay, so this is what we are getting. The expansion here is equal to, right? So this thing is equal to this, equal to this. Next. Now we can simply open it. When you open it, 1 by x is common. So let me write 1 by x outside. And inside I will get 1 plus x to power n plus k plus 1, n plus k plus 1, and minus 1 plus x to power n. And we are almost done. Now what we are doing, once we have written it like this, we would equate the coefficient of x to power n. Coefficient of x to power n in this should be same as the coefficient of x to power n in this. Because these two are same thing, no? Like this thing is equal to this, is equal to this. All right. So to find x to power, coefficient of x to power n in this, see, this is 1 plus x to power n. The coefficient of x to power n would be nc1. Means nc. Here it is. I think 1 plus x to power n. So that should be coefficient of x to power n should be ncn. Get it? Because if you are not getting it, because let me show you why I'm saying that. Because the expansion of 1 plus x to power n, 1 plus x to power n is 1 plus nc1x plus nc2x squared plus it goes on like that up to ncn x to power n. You know this all, right? So for that reason, we are saying ncn is the coefficient of x to power n here. N plus 1 cn will be there. N plus 2 cn will be here. N plus k cn will be there. So means we are getting our left-hand side. I mean, we're getting our expression, the one we were asked to find. We are getting nc1 plus n plus 1 c. Oh, I'm sorry, this is ncn. Yeah, ncn, n plus 1 cn plus n plus 2 cn plus it is going like that, and it is going up to n plus k cn. And the value of this thing what we were asked, value of this thing only we were asked. So this should be equal to, we are saying, the coefficient of x to power n in this. Can you find the coefficient of x power in this first? The first term. To find x to power n, you will have to find x to power n plus 1, because you have to later divide it by x also. Same here. You will have to find the coefficient of x to power n plus 1. But in this, because maximum coefficient of x would be n, you will not get x to power n plus 1. From here, you will get 0. And from here, you will get coefficient of x to power n plus 1 would be n plus k plus 1c n plus 1. And that is your answer. So this minus 0, right? When equating coefficient, we are saying, now this thing is same as n plus k plus 1 c n plus 1. That should be your answer.